The law of sines is one of the methods used for solving non-right triangles. Sine of angle A over side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. Now sides A, B, and C are corresponding to the different angles. If this is angle A, then the side across from angle A is side A. This is angle B, the side across from angle B is side B. And the same for side C. And as I said, this is just one of the methods used for solving a few types of non-right triangles. And I say only a few types because the only way I can possibly get an answer where I can solve for a triangle is if it fits into this ratio, and if I'm given certain types of information, it will not be able to work. But I suppose, let me do an example where it does work. So if I have a triangle, and let me say this is 60 degrees, this can be 40, and suppose this side is 4. And I can get this angle right here if I wanted to by just subtracting from 180 from these sides. But I'm not really going to worry about that right now. What I'm going to do is think about how to use the law of sines, and that way I'll know when the law of sines is applicable and when it's not. I can use this law of sines whenever I can get one of these ratios. So I'd have to get sine A, and so I'd have to get angle A and then the side corresponding to it, and then plus one other bit of information. So in order to use the law of sines, I need at least two sides and one angle, or two angles and one side. I can't have all angles and all sides, or I also can't have, let's say, a situation where I have, let's say this 4 was over on this side. Then this wouldn't work because I'd have 40 degrees corresponding to no side, and then I'd have 60 degrees corresponding to no side. So if I were to put this in a ratio, or I were to put this in the law of sines, there would be no ratio to compare it to. I'd have sine of 60 over, we'll just call that A, is equal to sine of 40 over B, and then I would have 4 over sine C. So I can't solve this because I don't have a ratio to compare it to. That's what I mean. Whereas this first example I do. So I have sine 60, and I called that one A. So let me just say that is side A. And this one was B. And in this case, if the 4 is on this side right here, then I do have a corresponding side to an angle. Sine of 40 over 4. I can figure out what this ratio is, and then I can solve for A. That's the basic idea of the law of sines. So let me go ahead and do that. So I'm putting into my calculator sine of 40 divided by 4.16. I'll multiply that by A. So let me just say, I just rounded this. So sine of, that's not what I meant. So let me just say I write it like this: sine 60, and I did this, and this was 0.16. So 0.16 A, divide 0.16 by sine 60. So A is equal to 5.41. So this side over here is 5.41. And then I can use this technique to solve 180. So these are 100s, this is 80 degrees. And then I can do the same thing again, where I have sine of 80 is equal to C. And then I can solve for that too, but I'm not going to bother. But that's the basic idea of it. But in the future, I'm going to learn I guess it's just a more versatile technique in the law of cosines. So I really wouldn't invest too much time in the law of sines, although the law of sines is good to know because it's very easy to remember. Sine of angle A over A, sine of angle B over B, sine of C over C. Very easy to remember. The law of sines, that's not very easy. Well, it's not that difficult to remember. There are just a lot more variables in it. And there's subtraction, so this is just very straightforward to remember. I always remember the law of sines. It's just very simple. But of course, it can't solve certain situations. A triangle where I'm given, again, where I have nothing but sides and no angles, or a triangle where I have nothing but angles and no sides, or the third situation where I have angles and sides but they don't correspond to each other, so that won't work either.